Okay, we should start. So thank you all for coming. So this is remarkably enough week 11 of this lecture series, and we're very happy this week to have Daniel Hume from 11 Madison Park. Who will get to speak in a minute, and he will give a lecture called Where is the Acid? But before he does that, you have to put up with me. So we have a fun game here in Science and Cooking. We have a fun game in Science and Cooking. We play this sometimes. It's a parlor game. We haven't marketed it yet. No one, to my knowledge, has done it. It's called Guess the Food. So would anyone like to guess the food? Yes. What? Peanut butter. Any other guesses? Yes, in the back? Chocolate. Yes? Bone marrow. Actually, bone marrow is the closest. This is beef. Okay, so guess the food. Here's another one. It's a good game, actually. Does anybody? Yes. Say again? Vegetable oil, that's very good. It's olive oil. Okay, very good. So, I mean, of course, the way that you play the game of Guess the Food is that you all know that there are major molecules in food. There are fats, there are carbohydrates, there are proteins, there's water, which is not listed on the food label. And if you look at those and you look at the percentages of the various things, you can sort of guess the food. So you guess the vegetable oil instead of olive oil because it was all fat. So what do you think it is? But, you know, the question that I want to raise is what else is important for food? That is, what else is important in a recipe other than this? I mean, look, if you have a jar of water, right, the number of molecules per liter in that jar of water is enormous. There's sort of, you know, more than 10 to the 23. There's about 10 to the 25 molecules of water that's in a liter of water. It's a huge number. But it turns out that, and this is the main thing, the idea I want to leave you with before I turn this over to Daniel, is that oftentimes there are ingredients in a recipe which are at very, very low concentrations, but yet are extremely important for taste. And just to demonstrate this, here is a typical recipe for a lemonade. And the question is what makes it taste like lemonade? Yes. The acid. Very good. That was in the title of the lectures. And where is the acid? The acid is in the lemons. Okay, very good. So in fact, the acid that's in the lemons is called citric acid. Here is a picture of it. And the citric acid is this complicated formula. It's chemical formula. And the main point of it is that an acid is something that more easily loses protons to water. So an acid releases protons, which are H pluses, which go into water. So even in water, there are protons that are in water in the form of hydronium ions. And the concentration of them is 1 part in 10 to the 7 of the moles per liter, which is more than 1/10 millionth. It's actually more than that. It's like 1 over 550 millionth of the atoms that are of the molecules that are in water are these protons. But yet, they're critically important for taste. This is what I want to tell you, that even though there are so few of them, they're critically important for taste. And when you see Chef Daniel do magical things with acids, then in fact, he's adding so few protons that if all of you in this room were water molecules, there wouldn't be one of you who is a proton in the dish that he makes. They're just so few, but yet they're critically important for taste, and you can control them by playing with things that Chef Daniel will play with. And I was going to turn it over to Chef Daniel.
Wow, thank you, Michael. How are you guys? Hey, thank you so much for coming. Thank you for having me here. It means a lot. It's a great honor to be part of this program. And I'm excited to talk about a little bit about myself, my story, the story of 11 Madison Park, and you know, a few things that I've learned along the way in the kitchen. But before I start, I have a confession to make. I never finished high school. In fact, I hated going to school. I hated going to classes and studying things I knew I probably never gonna use. When I was 14, I left school to be a cook. Obviously, that was not a very popular decision with my parents. But it's been the best thing I ever done. The things that the path of cooking has opened me to, it's been unbelievable. The people I've met along the way, I've traveled the world, learned about different foods and different cultures. I learned languages. The opportunities just have been unbelievable. 8 years ago, I came to this country with 2 suitcases, mostly full of chef clothes, cookbooks, some knives. I had a couple $100. I did not speak English. Now I'm here, speaking in front of you at Harvard. That's insane. This is one of the best schools in the world, maybe the best school in the world. This is the American dream. When they first asked me to speak here, I wasn't sure if I'm the right candidate, because I'm not a public speaker. This is totally out of my comfort zone. I'm nervous standing up here. I'm a cook. The place where I feel comfortable is the kitchen. But as I thought a little bit more about the opportunity, I knew that there are definitely things I have to share. It's amazing how food has changed over the past few years. Now everyone in the world wants to know about food, chefs, and restaurants. When I started 25 years ago, there was no food and science program at Harvard or at any school. There was no Food Network. There weren't all these TV shows, all these magazines. For sure, there were no celebrity chefs. Back then, it was just about the craft of cooking. I fell in love with it because I love the energy in the kitchen. I love to work with fresh ingredients. I love to work with my hands, create something with my hands. Cooking is very tangible. Something my dad always used to say, he said, it doesn't matter when you're passionate about something, how big or small it is. The only thing that matters is how much effort you're willing to put towards that. And that's what cooking has been for me, and that is what 11 Madison Park represents today. I have this clicker here in my hand. Been holding it really awkwardly. I've never used one of those. So I just gonna give it to Mike. To put something together like this, or to do anything great, it always takes a team. And I want to say thank you to a few people that have helped a lot with this. I want to say thank you to Mike Pyers. I want to say thank you to Connie Chung. Both of them are chefs at our restaurant and are in charge of all the research and development. I want to say thank you to Aaron Ginsberg, who is our director for strategic development, and he has spent hours with me practicing this. Literally hours. I want to say thank you to Ali Bouzari, who is a friend and the scientists who helped so much with this and made sure we have all the facts straight. I also want to say thank you to my business partner, Will Guidera, and my best friend. I want to say thank you to a few things. On one side, I want to say thank you to create a culture of hospitality and service that has set new standards in our industry. Because we can talk about food and work our time in the kitchen, but if the hospitality and the service sucks, it all doesn't matter. So thank you for that. In addition, I want to say thank you for supporting me, teaching me, pushing me to do things I never thought I could. I also want to say thank you to my girlfriend, Kara, and her mom, who are both here today, because we can have all the support professionally and at work, but you also need the support at home. So please give a hand of applause to all of them. So let me give you a little context about the restaurant. 11 Madison Park is in the heart of Manhattan. It's on Madison Avenue and 24th Street. It's in a beautiful Art Deco building. The building is occupying an entire city block. In fact, the building was supposed to become the tallest building in the world when it was built in 1928. But due to the Great Depression, the build was halted. But what we ended up with is this incredible dining room, 30-foot tall ceilings, huge windows overlooking Madison Square Park, one of the most beautiful parks in New York. You even can see the Flatiron Building. Imagine this dining room was supposed to be the lobby of the tallest building in the world. There is no other restaurant with a better view than ours. It's such a New York space, such a New York room. So it's important that through the experience, we pay homage through our food and through the delivery of the food to the place we're in. Our inspiration comes from fishermen, farmers, artisans, all around New York. What people don't realize when they think about New York, all they think of is Manhattan and this concrete jungle. But we're on the Atlantic coast, which is one of the most amazing waters for seafood. Also, when you drive just a half an hour north, you reach farmland for hours and hours and miles. The Hudson Valley, the Finger Lakes, have some of the most amazing conditions for agriculture because of its soil, the surrounding waters, and this amazing climate. But in addition, what we have New York City, hundreds of years of history. Immigrants from all over the world came to settle this place. They all brought food traditions. These traditions have evolved, and new traditions have been created. Eating at 11 Madison Park is the intersection. I can hear my business partner will laugh through the whole. It's the intersection between, on one side, we have these amazing ingredients, the amazing agriculture, and on the other side, we have this rich history and culture of New York, the place that is our home. But that's not why I'm here today. I'm here to talk about acid and acid in food. Where is the acid? My staff hears me say this more than they probably care to remember. But where is the acid is really the central question when we create a new dish. When seasoning food, Everyone talks about salt. I believe acid is just as important, maybe more important than salt. When I grew up in Switzerland, I was always drawn to acidic foods. I love tomatoes, I love citrus fruits, I love pickles. My mom's cooking, sauerkraut, roasted chicken with lemon and rosemary. She made a braised rabbit with olives, orange, and pickled onions. I never knew exactly why I was drawn to these dishes so much, why they were my favorite. But looking back, it makes sense because there was presence of acid, which gave it balance and it highlighted the food. At 11 Madison Park, why does this matter so much? Well, I think acid catches your attention. I think when you taste acid, it kind of wakes you up. And it just makes food better. Acid just makes food better. At 11 Madison, we serve tasting menus, 14, 15, 16 courses. It's important that all these dishes have acid. We use acid from so many different sources, but it keeps the guest excited, it keeps the meal lighter, and it makes the guest want more. Our food is different than, let's say, traditional French food, where it relies heavily on butter, cream, and fat. Until a few years ago, we never really thought too much about the amount of acid we're using. But then we started kind of digging into our food and trying to understand our food a little bit more. And we realized that the acid is the foundation of our cuisine. And as we dug even deeper, we realized that acid was doing so many other things. And these three things I want to tell you today about. Number one, acid affects the flavor in food. Number two, acid affects the structure in food. And number three, we use acid to preserve food. Let's get into flavor. Obviously, flavor comes first. It's the most important to us. We want the food to be delicious. When we add acid to food, it changes how you perceive the other basic tastes. It interacts with the saltiness, the sweetness, with umami, and with bitter. A great example for this, and I'm sure you've all seen it, but sometimes you get an espresso with a slice of lemon. That lemon is there to squeeze lemon juice in the espresso. What it does, you add sour to the bitter, and it makes you perceive the bitter as less bitter. Thankfully, coffee has gotten a lot better over the years, so you don't see that much anymore. But that was the reason why. We also looked at some manufactured foods. Coca Cola, soy sauce, ketchup. All these rely heavily on acid. For the same reason, it balances the sugar, the saltiness. But here's something else. It also makes food more have a better shelf life. These ingredients sometimes sit on the shelf for 2-3 years. Really, 2-3 years. And you taste it, and you still sort of feel like they're fresh. Acid also affects the aroma in food, and that is really important for us in the kitchen. We play with this all the time. Let's say we make a lemon sorbet. Let's say we make a lemon sorbet just using lemon juice. That's like every lemon sorbet that's out there. It's good. It's a good lemon sorbet. But let's say we also introduce aroma to this lemon sorbet. And the way we do it, the sugar that is required to make that sorbet, we take sugar cubes and we rub it on the skin of those lemons and then season the sorbet with that. So now we're also introducing aroma. And now when you taste that lemon sorbet, you smell that lemon sorbet, and it elevates the flavor of that sorbet. The same thing happens when you peel a grapefruit. I'm sure you've all peeled grapefruit before you eat it. When you peel it, the aromas, the oils, they're on your hands, they hit your nose. And by the time you eat that grapefruit, it tastes unbelievable. The best grapefruit you ever had. It tastes much better than a grapefruit you would just get served on a plate that's been pre-sliced. In cocktails, we use it a lot. If you're at the bar and you're ordering a Manhattan, I don't know if you're old enough, everyone in here, but if you have a Manhattan, the bartender at the very end of serving you that drink adds a twist of orange. That twist of orange, that aroma hits your nose, it elevates the flavor of that drink. All these things happen because your brain is making a connection between what it tastes and what it smells. It elevates the experience. It's like going from black and white to color. We have some bags here for you, and I'm sorry, Michael, we weren't quite as prepared as I wanted to, but we disturbed your talk a little bit with bringing in these bags, but here you have it. Please grab in these bags. There are 2 small bottles. I want you to just take out the 2 small bottles. Okay. And now put the bag back down. We're going to taste these. I would like to taste these as well.
No.
Thank you. In these 2 bottles, we have soda. We've made a lot of different sodas over the years. Celery soda, cherry soda, coffee soda, strawberry soda. But for you today, we have maple soda. I want to taste the first one without the sticker on it. It definitely tastes like maple syrup, but it tastes really sweet also. In fact, it's good, but I wouldn't really want to drink this soda. It's too sweet. It's not balanced. Let's taste the other one. And it's pretty impressive. Our team filled all these small bottles this afternoon. And even, I don't know, yeah. Even more impressive is that they're still cold. Let's taste this one. These sodas are made exactly the same way. It's the same recipe. There's one change. And this soda, for me, tastes a lot less sweet, a lot more balanced, a lot more delicious. Kind of like what you want soda to be. We added in this case, apple cider vinegar to balance this out. So this is an example I wanted to give you because it kind of is a strong example. And the soda goes from really not really drinkable to delicious. In food, it's not always this extreme. It can be much more subtle, but it can elevate the right amount of acid, can elevate the experience of a dish. Let's talk about our first dish here. This dish is a seafood boil. It's inspired by a seafood boil you would have out by the water on the ocean. This seafood is extremely fresh. There is prawns, lobster, clams. It's amazing seafood. You could just steam that and eat it, and it would be delicious. But what we do, we cook it in a broth of lemon, beer, and tomato. We then bring it out to the dining room, and we put a big wooden board right in the middle of the table. We take that seafood and we dump it right onto that board. We're asking our guests to eat this dish with their hands. But before they do, we're asking them to squeeze some fresh lemon over that seafood. So now we're introducing aroma to already the acid that we introduced during cooking. It elevates that seafood. It makes it a better dish. Our next dish is a roasted duck. This dish is on the menu all the time. These are these amazing ducks we get up from the Finger Lakes. We're really proud of the product and the preparation. It's glazed with honey. On this picture, we serve it with rutabaga, whipped honey, some bee pollen, and then a sauce that is made with caramelized sugar, duck shoe, and there's 4 acids in this sauce. We have lemon juice, lime juice, orange juice, and vinegar. The duck is gamey, meaty, fatty, and rich. Now we're also adding sugar in the form of the honey and in the sauce. So it's really, really important that we're playing with a lot of acids. And it's sort of like the sensation of sweet and sour. Here we have oysters. We get these oysters from Long Island. They're 2 hours away from a restaurant. We get them every day, and they're as fresh as an oyster can be. You could just shuck them and eat them right out of the shell, and it would be delicious. These oysters are served with champagne grapes, a snow that we make with Concord grape juice and red wine vinegar, and we also have sorrel. A lot of the guests come up to me and say, wow, these are the freshest oysters I ever had. Or they come to me and say, wow, the combination of oysters and grapes is unbelievable. And that's cool. But what they're really responding to is the high amount of acid that is in this snow. And it makes them believe they've had oysters this fresh before, but the high amount of acid makes them believe that these are the freshest oysters they ever had. It's the same thing that we talked about manufactured foods. They add acid to make shitty food taste better. But if we use that, and we use the best ingredients that we can get our hands on, and we're adding acid in the right amount, we can make a great product into an unbelievable product. Here we have the second one, structure. Just like we did with this spoon, acid changes the structure in food. We took this spoon, we bent it, it changes the function of this spoon. Here we have milk. We're adding acid. We're changing the structure of the molecules in that milk, and it turns it into curd. This is the basics of cheese making. I want to show you this in one of our dishes where we use that to our advantage. Here, all the way on the left side, you see a pot with milk, and there's some hay in it. And the hay is there to flavor the milk, and there's also lemon juice in that milk. Now we're bringing that milk up to temperature, and you can see how it starts to separate. Then we're straining it. So now we have the curd on one side and the whey on the other side. The whey usually is a byproduct, and it gets thrown out. But what I love about this dish is how we bring these two ingredients back together. We're making a gnocchi. We're taking the curd and we roll it in semolina. We're taking the whey and make it into a really flavorful broth. We serve the gnocchi with some beautiful greens, and we pour the broth tableside. This is a dish of scallops, and it's a raw scallop just marinated. We get these amazing scallops, we open them fresh out of the shell. They're still alive. We marinate them with green apple juice so the scallop firms up. It changes the structure in those scallops. And Michael was just flying through this thing, but he touched on ceviche. But it's the same thing that happens with ceviche, the lemon, lime, or pineapple juice. It changes the structure in that seafood, and it gives it a different texture. The apple juice that we use to marinate the scallop is also affected by that. We're adding citric ascorbic acid to this apple juice, and we use it because it's close to flavor neutral. But yes, the addition of ascorbic acid keeps the apple juice from turning brown. This is the same thing that happens when you make a guacamole. You add lemon to that avocado so it doesn't turn brown. The same thing can happen with mushrooms or when you peel artichokes. Here we have egg yolks. I love eggs. Eggs is probably one of the most versatile ingredients that we work with. And all the way on the left side, the top part is a raw egg yolk. On the bottom, we open it up so we show you the consistency. Egg yolks are extremely creamy, but we tried to find a way. How can we make it even creamier? In the middle, we took the egg yolk on the top and we marinated it in white balsamic vinegar for 2 days. On the bottom, in the middle, we opened it up to show you the change in consistency. That egg yolk got thicker, creamier. And then we took it even further. All the way on the right is an egg yolk that's been sitting in white balsamic vinegar for 7 days. And you can see on the bottom picture, all the way on the right, that now the egg yolk is barely liquid anymore. It's gotten a lot firmer, and that's pretty cool. Here, this is an experiment that we did just for today. This is red cabbage. And red cabbage is functioning like a natural pH meter. We added acids and we added alkalines. And just based on those colors, you can see the change in pH. All the way on the left, we added white wine vinegar, the most acidic things we added of all of them. Then we added white wine. The third one, we actually just added cabbage juice as being the neutral one. And then we're adding alkalines, which the blue one is baking soda. Then we added lye, and then we added bleach. Obviously, you don't want to eat this, but this is really cool. Just by the change of pH, the color changes, and these are bright colors, dramatically. This happens with other things too. For example, a blueberry muffin. You've all had blueberry muffins. When you look at a blueberry muffin, sometimes you see around the blueberry a small circle of green. The blueberry is starting to turn green. This happens because the baking soda is interacting with the acid in the blueberries. When you see that, it's usually not a good sign. It's not the best blueberry muffin you ever had, because it means there's too much baking soda in it. But that's what happens. And the same thing happens right now. You walk outside on the streets, and you see all the leaves changing on the trees. There's other things that go on there, but one of the biggest reasons that these leaves are changing color is because the pH level in these leaves is changing. Preservation. Acid is involved in two types of preservations. On one side, we have pickling, and on the other side, we have fermentation. If you take this cucumber here, if you just let it sit, bad bacteria will grow. And I know the picture of these bacteria is kind of ridiculous, but somehow I wanted to make this point. If you let this cucumber sit, these bacteria will grow. It will destroy the cucumber, or it will destroy you. In the presence of acid, bad bacteria dies. Come on. In pickling, we simply add acid in form of vinegar. In fermentation, acid is naturally produced, which will keep the bad bacteria from growth. We use this all the time. Here on this picture, we have pickled purple eggplants. The one on the right is just a raw slice. The one on the left has been pickled. What's really cool here too is because of the eggplant's purple skin, it penetrates that color throughout, and it looks really beautiful. Here we have pickled plums. Sometimes we use the sous vide method for pickling. Pickling under pressure speeds up the process of pickling. Here we have fermented mustard greens. We simply let these mustard greens ferment by adding salt, water, onions, and ginger. And again, through the fermentation process, acid is produced, and it will keep bad bacteria from growing. Here we have a foie gras dish that we serve in a restaurant. It's a foie gras dish with sunchokes. I love this dish, and it's a dish that we serve during the winter months. And I love this dish so much because preservation allows us here to use ingredients that are out of season. On this dish, we have fermented mustard greens, and they're a little hard to see, and I think we could have picked maybe a better picture, but I promise you they're there. We have pickled sunchokes, and we have a relish of onions and mustard seeds. I love how preservation is helping us in this dish. We're using ingredients that are out of season. But in addition, also preservation is bringing acid to the dish, which helps balance the flavor of that rich and creamy foie gras. We could talk about this an entire lecture and more. It's a really complex topic, fermentation, preservation. And I know a week from today, Jody Adams will give an entire class on fermentation. Let's get back to our original question. Where is the acid? We use many different acids from all kinds of places. So let's look into our pantry. This is a picture of our dry storage. We have bottled vinegars that we buy from balsamic vinegars, Banyuls vinegars, sherry vinegars, red wine vinegars. We have all kinds of vinegar powders that we're using. Malic acid powders, lactic acid powders, citric acid powders. We're also making our own vinegar. We have a vinegar machine, and then we age the vinegar in barrels. Making our own vinegar allows us to be very specific to our dishes. In our walk-in, we have all the fresh dairy that brings us the lactic acid from creme fraiche, yogurt, cream, and milk. And then, of course, we have all the fruits, citrus fruits, apples, pineapples, that give us acid. We're using a pH meter at the restaurant, and we're using it as a measure to give us more consistency, more accuracy. We're using it in a way we use a scale, or in a way we measure temperature. I want to talk a little bit about some of the pH levels that we've learned about. And I want to start with water. And remember, I'm sure you probably all know this, but I want to remind you that the lower the number in pH, the higher the acidity. So we took our still water, and this is the water we serve with our meal. We took still water and we measured it at 7.5. 7 is neutral, so it's very close to neutral. Then we measured our sparkling water, and our sparkling water is highly acidic. And then we even ask ourselves, is it just the bubbles? Or when it goes flat, will the acidity remain? And it does. What's cool about here is that we actually learned that CO2 is a source of acid. So we can add CO2 to anything, and the acidity in that will increase. But then there's something else. When you go have dinner, the most simple question in the beginning of your meal, do you want still or sparkling water? This question is not that simple anymore. Because it changes the experience of your meal dramatically. We also looked at the manufactured foods that we talked earlier, and we measured those. They're highly acidic, all of them. But the most surprising here was Coca Cola. Everyone in the world drinks Coca Cola. Everyone loves Coca Cola. Coca Cola is more acidic than red wine vinegar. Just imagine that. Isn't that crazy? You eat that with your meal. It's more acidic than red wine vinegar. That's unbelievable. And when you drink Coca Cola, you never think of it as being acidic. And that is why, and that's because there's so much sugar to balance all that acid and makes it a beverage that everyone loves. I talked about this dish earlier, our duck dish, and I told you the sensation of sweet and sour and how crucial the sauce is. The perfect level in this sauce of pH is 4.6. So I wanted to see if we take our cooks, our line cooks, and we have them make this sauce over a period of 3 weeks, make it blindly, without a pH meter, just by taste. And this is what they came in those ranges they came in, between 4.3 and 4.9. It's pretty close, don't you think? It's really close, and it's just by taste. So then I wanted to see, okay, let's take our more experienced cooks, our sous chefs, and let's have them do the same thing and see if they could get it closer. And thankfully, they did. But hey, just to be clear, when I make this sauce, but so that's great. We have pH levels, and it helps us to make it more accurate, and it's a great tool. But even if that sauce has the perfect pH level, it doesn't mean the sauce is delicious. It can taste totally off. And I think that is where the magic of cooking comes in. We can have all these scientific tools, but it will never replace the palate or the talent of the chefs who are in the kitchen. Talk about wine. Hey, and this is based on the people I worked with on this. You might drink different wines at Harvard, but wine, we can't talk about acid and not mentioning wine. Wine is such a big part of a restaurant, of a dining experience, and acid in wine is so important. We have the wines on the left that we pair with our food, and then we have the wines that you might drink in college, and we measured those. And for our pairing, remember our food is highly acidic. So what we need a wine to be a perfect pairing, to pair food. You need a wine that is just as acidic, maybe even more acidic. And what that does is it lets the flavor of the wine come through. It lets the wine be wine and not be overpowered by the food. Although the wines on the right, that was a surprise to us because these wines, they're highly acidic. When we drink these wines, we think of them as extremely sweet, very high in alcohol, and very low in acidity. So we were surprised to see these numbers. So again, the pH level is not, you can't taste the pH. In these wines of lesser quality. There is acid added artificially to balance all that sweetness and that sugar. And that's why when you drink cheap wine, you have a way worse hangover than when you drink good quality wine. There is a common theme. Manufactured foods adds acid to make bad food taste better. The wine industry takes this really sweet, high alcoholic, bad grape juice. They add acid and they can sell it. If we take that knowledge and we add it to the best ingredients we have and we use it carefully, we can make food from great to unbelievable. It affects all levels of food. On every level, acid changes and highlights the ingredients. So I've been talking a lot, but I want to talk about one more dish. And this dish I'm really excited about. This is a dish that we serve at the restaurant. We've been serving it for a long time. It's a dish that a lot of people talk about and people really love. It's a dish of carrot tartare. This dish is inspired by a classic New York steak tartare. And we worked on this idea for a while. This is what we came up with. Also, I think it's what we talked about earlier, the intersection between great ingredients and the history of New York. I think it's demonstrated in this dish really well. We have these amazing carrots from upstate New York, from the Hudson Valley. We get it from a farm. His name is Alex Pathenbrod. This guy's been growing carrots for the last 40 years. He grows about 40 different types of carrots. These are the best carrots I have ever tasted. We wanted to make them the star of this dish. And the way we serve it, we bring out this meat grinder into the dining room and we clamp it onto the table. At this point, the guests don't really know what to expect. They expect to be meat. But then we come out with these amazing carrots. And in this dish, we demonstrate all three things that we talked about today. In this dish, acid affects the flavor in food. In this dish, acid affects the structure in the food. And also, we're using acid to preserve food. So the cook comes out and grinds these carrots tableside into that board. And on that palette of ingredients, we ask our guests to be their own chefs and add these ingredients to their liking and mix it together. We have a marinated egg yolk, what we talked about earlier. We have pickled mustard seeds. We have compressed apples. We have a mustard of apple. And we have a carrot vinaigrette. And now, in your bag, there's a jar with this dish already mixed. We also have a little bag of some rye crackers. You can dip them in. I would have loved to bring like 300 meat grinders and make that dish for you, but I couldn't. So this is already mixed, and please taste it. Acid is so important in this dish, you can taste it. And acid, in a way, it's such a simple thing, adding acid. But then also acid does so many complicated things that we didn't know and we simply took for granted. There is one more thing in that bag for you, And anyone who leaves our restaurant at 11 Madison leaves with a jar of granola. The granola has nothing to do with acid, but we're also in the hospitality business, and we just wanted you to have a delicious breakfast. Thank you, guys.